All right, let's get started. Before we get started, though, let's do a little quick review to get your brain fired up again. Solve both of these, please. But hey, thanks a lot. Appreciate it. All right, thank you. Have a great day. Bye-bye. What are you going to use on the left side? Product rule. Right side? Quotient rule. Good. So far, so good.
She's a product rule. You know what that means?
The product rule?
Yeah. Same thing. Just put it, raise it to -1.
That's today's lesson.
So you're telling me
Am I-
there's an easier
Is there an easier way?
Easier is relative.
easier to ride through?
I would encourage you to use the product rule on the left one, but if you wanted to multiply it out, you could. Once you get an answer, check with your neighbor to see if he or she has the same answer. If so, high five. If not, argue about who made the mistake.
I'm not there yet.
Do you know how long that takes? It takes like hours to make. Why isn't it possible? No.
You made that? You made that?
No, he's talking about the cake.
Like, you want plus 20x cubed minus 42x squared plus 6. Did you do both?
No, that takes hours.
It is plus 6. It's minus.
You don't do it.
No, but the solution is minus.
Thank you.
He's gotta be negative.
All right, we good?
Everything
No,
is
not yet.
Okay. How about now?
No.
Okay.
This is too much pressure. Should we move on to the quotient one?
This is too much pressure. Wait till May. Your head will explode.
Is it? You take the derivative, the second one times the first one minus the derivative times the second one all over the second.
Yeah.
Yeah? Are you sure?
I mean, if you said what I think you said, but I'm pretty sure.
Question, sir.
For the second one, it's derivative of the second times the first minus the derivative of the first times the second all over the second.
I do it differently. I put the denominator on the bottom and square it, bring the denominator to the top times the derivative of the numerator minus the denominator times the derivative of the numerator.
I messed up.
I understand. Common mistake with the quotient rule. All right, let's get going. So if you didn't finish, I'm sorry, but we need to move on. You should have gotten these two answers. Okay. How many people got them both right?
I've been out of the game.
Oh, good. Got one of them right? Didn't finish.
I flipped this one the last one, but it won't.
Okay, so today we're going to do something called the chain rule, which, as Mr. Beloff alluded to, will allow us to solve the second problem on the right in a different way. So again, it is called the chain rule. And we'll go through our objectives first. You should be able to use the chain rule, because it's called the chain rule. the basis for the chain rule is to solve the derivatives of composite functions, but you'll see that we can take that quotient rule and turn it into a composite function. We're also going to talk about what's required to get something that's considered a simplified derivative. And then we're going to look at some trigonometric stuff, because life wouldn't be complete unless we talked about a little bit of trig. And then, of course, being seniors in high school, you should be able to recite the state capitals. Anybody?
I used to be able to.
Used to be able to.
Like, but I would.
Did you just sing that Animaniacs song?
Yeah,
Good, you got one. You're gonna do them alphabetically too?
It's not one,
You're gonna show them.
Sacramento.
If you name a state, I can.
Okay, Alaska.
Capital of Maine?
Nope.
Alaska's Juneau, isn't it?
I just said Juneau. That's why I just said California. Wait, I'm finished now.
Alright, here we go. So, we're gonna start with the calculus speak first, and then we'll get into the mechanics of how you do it. The calculus speak is a little confusing. The application is a little bit more straightforward.
Is this
2.4, yes. Okay. What we're going to be looking for here are composite functions. In other words, functions within functions. So notice all the functions on the left-hand side of that column are single functions. Okay. This is a polynomial. This is a trig function. Another polynomial. Even that is a single function. Okay. It's just a series of terms added together. The ones on the right are composite functions. So this is x squared plus 1 put into the square root function. This is the function 6x put into sine, etc., etc., etc. When you're looking at those functions, one of the things you're going to have to be able to identify is how many functions make up that equation. If you can do that, the chain rule is not too bad. If you struggle with that, you might do more than you need to, which is going to cause a world of hurt. Okay, so we'll go slow here. All right, there it is first. So this doesn't make much sense because we don't deal with this a lot, but it allows us to write that dy over dx by breaking it into the derivative of y with respect to u and the derivative of u with respect to x. This bottom one makes a little bit more sense. A little bit more. If we want to take the derivative of a composite function, we take the derivative of the outside function times the derivative of the inside function, which there it is in English. That's if you have only two functions. And of course that would be too easy if we just stayed with two functions.
Should we copy down the first sentence? Is that
This is America. You do whatever you like. It's in the book. That stuff in the blue box is in the book if you want. If it doesn't make any sense to you or it's not going to be helpful, don't write it down. If you're writing it down just so people think you're cool when they look at your notes, don't write it down. If it means something to you, write it down. Pretty much beat a dead horse on that one, right? Good. Okay, so here we go. This is the key. You want to ask yourself, how many functions are we talking about? How many functions within another function? And then you're going to chain on one last time. Okay, so for instance, if my function is based on three functions, you're going to chain twice. And that's important because we will see some functions where you can just keep chaining over and over and over and again. And what I mean by chaining is you'll see in a second. You want to be able to identify how long do I go before I stop. Otherwise, again, it's going to be a whole big nastiness. Okay, that's what I just said. And so let's look at this one. How many functions make up f of x there? Two. What are they?
You said 2x minus 3 and then 1 over x squared.
Or raising to the negative 2 function, right? So 2x minus 3 is the first function, and then the other function is raising it to the negative 2 power. Well, I understand. Okay. Which one's on the inside? Good, the 2x minus 3. So think about this, that we're going to work from the outside, sorry, from the inside out. I said that wrong. From the outside in. Okay. It's like peeling an onion. Now this is how the process goes. And this will make a little bit more sense when you watch me actually do this. If I consider this, and for some of you that start, you might want to do a substitution here to make this a little bit more clear, but I'm going to do it without a substitution and hopefully it'll make sense. The negative 2 power is on the outside. That's our outside function. So I'm going to take the derivative of that function, whatever it is, raised to the negative 2 power. So what's the derivative of anything raised to the negative 2 power? Negative 2 times that function, which is 2x minus 3 in this case. And then what do I do with the exponent? Reduce it by 1. Okay. That's the first step. Now here comes the chain. Now we have to take the derivative of the function inside. Because there's 2 functions, we chain once. So what's the derivative of the function inside? 2. Okay, we're done. There's some cleaning up to do, but I don't care about the cleaning up right now. I just want to make sure you understand what's going on here. Okay. 2 functions, chain once. Work from the outside in. Anybody freaking out yet?
Wait, where'd you get the 2 from
I'm
again?
getting there.
Which 2?
The
This?
Yeah.
This is the derivative of the inside function.
Okay.
Okay?
Wait, is the equation f, finding the derivative of f of g of x, is that f prime g of x times g prime x?
Yes.
Or is it f prime g prime x?
F prime of g of x times g prime of x. 8 times.
So f prime of g of x, that would just be like a negative 2 and then.
Okay, and again, let me show you another way to do it. If some of you are confused, you could do this. Make u equal to 2x minus 3. So you could rewrite this function as u to the negative 2. Okay. Derivative of u to the negative 2 is negative 2u to the negative 3, and then you have to chain on the derivative of u, which would be 2. If that works better for you, go ahead. But I think in the long run, this will work better for you. Okay, let's do another example. Okay. Notice that this is 2 functions. What are they? The one in the middle and the one on the outside. The x to the 4th, the quartic in the inside, and the raising it to the 4th power. So it's a quartic within a quartic. Whoops. So there's the derivative. Now notice what I did here. I treated this as one function. I'm working from the outside in. So what's on the outside is the 4th power. Bring the power down, reduce it by 1. Don't do anything with that. Since I have 2 functions, I chain on 1. So I take the derivative of the stuff inside, and I get that. This is a perfect example of what I talked about before. You have to be able to identify how many chains you need. Because notice what could happen if I'm not paying attention. I could then chain on again and take the derivative of this and get 12x squared plus 6. And then I could chain on again, and I could keep going until eventually I would get down to 0, which makes a derivative 0, which it's not. So you chain 1 less time than the number of functions that you have. Okay? This will be fun. Here we have 2 composite functions multiplied together, which means I'm going to need to use the product rule. Because I don't know about you, but I don't want to multiply that out. Okay. Within the product rule, then, we're going to do chain rules. So let's start and make some notes before we get going. In this part, how many functions? 2. So how many chains? 1. Good. How many functions here? 2. How many chains? Okay, product rule. G prime of x. What do I do first? How's it again? Say it again. Go ahead, Mason.
I would write a 4.
A 4 is a good start. Where'd that 4 come from?
The 4th power,
Good. Bring the 4th power down. Now what?
4s g plus 3. So 3rd power.
Good.
times 12x, well, in parentheses, 12x squared.
No.
No,
Oh, yes, yeah, you're right. Sorry, go ahead.
12x squared. Oh, yeah, I guess you really need parentheses.
Keep going.
1/2. 1/3. Oh, 1/3. Yeah.
No, not yet. Product rule. Derivative of the first, which he just did. Is everybody with me there? Or with him, I should say. He just took the derivative of that first equation, or first function.
Oh, product.
Right, product rule. So derivative of the first times the second. I'm going to write this as raising it to the 1/3 power. Plus the first.
Yeah. Times the derivative.
Times the derivative of the second. Go.
1/3 times root 3 2x plus 1 to the negative 2/3 all times 2x plus 1 or well no 2 to the negative 2/3.
Just two.
Oh, just 2.
Who said that? Why? You just throw out a 2?
That's the
Well, let's
derivative of
do
the
the
inside function.
Good. It's the derivative of the inside function. So that's our chain when we took the derivative of this monster. What's the matter?
Wouldn't it?
That's
Oh yeah. Okay, yeah.
Okay. Times?
What? Oh my
What?
God, there's more?
no, say nothing.
Oh, yeah.
What?
Oh, no, I didn't. I wrote it already. Sorry. Times nothing. Good job. Way to go.
Is that
Times 1. Yes, sir.
Do you have to like then multiply the side, or is that?
Oh, yeah, there's a little bit of more work to do, but we don't care right now. That's coming later in the slideshow.
Exactly.
So we could simplify that. One thing we're not going to do, seldomly if ever, is multiply these monsters out.
Question. Can you
Okay.
explain what you did?
Can I explain what I did? Sure. Mason, can you explain what you just did?
Well, you use the chain rule and the product rule together. Since you have two functions in each part, you have to use the chain rule for each specific part, and then put them together using the product rule. So you did the same thing as you did above with the first part, because you need the derivative of the first piece of, you know. You need the derivative of 4x cubed plus 3 to the 4th, which is 4 times 4x cubed plus 3 all to the 3rd times 12x squared, as he pointed out. And then you do the multiply by 3rd root of 2x plus 1. And that's the first part of the product rule, because it's got f prime of x times g of x. And then you add f of x times g prime of x, which is the derivative, as he pointed out, of root 3 times 2x plus 1.
Awesome. Did we lose anybody?
Yeah.
Oh, yeah, we can
We
close.
lost it. We lost guys.
Wait, so.
Okay, so let's back up. On the first example that you did before we started on chain rule, we did the product rule. And the product rule is the derivative of the first times the second plus the first times the derivative of the second. That's what he did.
Yeah.
In order to do that, however, in this particular problem, we need to do chain rule. So he took the derivative of the first. There's two functions there. So he's going to chain once. Takes the derivative of the outside, move the 4 in front, reduce the power by 1. That's all he did here. And then chained on the derivative of what's inside. So the derivative of that function inside is 12x squared. Times the second. This is just that rewritten. Plus the first, so just copied that function down, times the derivative of the second. That's the same thing as 2x plus 1 to the 1/3. So brought the power down, reduced it by 1, leave that inside thing alone. And since there's a function, two functions there, we want to chain once. Took the derivative of 2x plus 1 to get 2. Done. Just for giggles, if I asked you to simplify that, what would you do, Luke? Before your head explodes, because it looks like it's about to go.
How can you tell?
I don't know.
So, how to simplify that?
How would you simplify that?
I multiply it out.
Whoa. You would?
Use the power rule.
Or you could use the power rule.
No, because we don't have to take a derivative again.
Could you
Eitan?
If you just like try factoring out.
Perfect. What would you factor out? What do these two terms,
2x.
what does this term and this term have in common? Is that you? Mr. Belloff, what do those two terms have in common?
They have a 4x cubed plus 3 to the third power.
Is that it?
Well, that's what I did. That's one thing they have in common. They have
Good.
2 in common.
What's the other thing they have in common?
How about the favorite color?
They have a 4x cubed plus 3 to the third power in common, and they have a 2x plus 1. The question is, which power will I take out? So write this in your notes because this is going to come up a lot and it'll come up later in the slideshow. Always factor out the smaller exponent. So in this case, we would factor out 2x plus 1 to the negative 2/3 power. You'll see why in a little bit. It makes things a lot prettier. Always factor out the smaller exponent. Okay, you having fun yet? Okay, that's about as bad as it gets.
Right, I thought you were gonna show.
So,
Wait, so
it-
wait,
You said wait
three,
until
so we
May.
factor out the negative
2x plus 1 raised to the negative 2/3 power. Okay?
Wait, then why'd you say wait until May?
I'm erasing.
Wait, whoa. Can you do it that on paper? Can you factor it? Yeah.
You want me to factor that for you?
Yeah.
Sure. I'm running out of, here, I'll move up here.
No, do it on the one.
Yeah, you have stuff on this.
Okay, so I would take out g prime of x. I would take out a 4x cubed plus 3 to the third power, and I would take out a 2x plus 1 to the negative 2/3 power. Put in a big honking bracket there. Looking at the first term, if I take this stuff out, I'm left with a 4, a 12x squared, and this goes away, the 4x cubed plus 3 to the third power, but what does that leave behind? That's going to leave a 2x plus 1 raised to what power? No.
No power.
Oh,
No power? 0?
No, 1.
1, correct.
I'm gonna do this tomorrow.
Oh, is
So
it
it's a negative 2.
When you factor out, factoring out is the same thing as dividing, right? And what do you do with exponents when you divide? Subtract. 1/3 minus negative 2/3 is 1. And that's why you take out the negative exponent, because it'll make the exponents nicer. Plus, I'm left with one of these, 4x cubed plus 3. And then back here I'm left with a 2/3.
Is it to
Yes.
No, because I took out 3 of them out here.
Okay, this is.
When you factor like that, you're not going to play with any of these. You're going to leave them alone. You are going to simplify this, however. So there's no way to avoid it. You're going to have to multiply this out. Now, why are we going to be factoring things out? Because notice what we did. We took g prime of x, which was a sum, 2 things added together, sum, and we turned it into a product of 3 things. That's important. Because later on we'll be applying the zero product rule and setting each of them equal to 0 and solving and all kinds of fun stuff. Okay? Let's move on.
Mr. Eddie, where'd you get the 2/3?
The 2 and the 1/3.
What about the 4 from the front?
What about the what?
Oh, you did it.
It's just.
Okay, we good? I'm erasing now.
Wait.
Too late. Okay. We pretty much covered this, but let's go through it anyways. Here's the first problem. Before we do this problem, though, let's talk about what we talked about originally, and that is, what if this squared wasn't here? How would you take the derivative of that? Quotient rule, correct. Okay, what we can do now, though, using the chain rule, is I could rewrite this as 5x minus 2 times the quantity, x cubed minus 3 raised to the negative -1. Okay. And you could turn a quotient rule into a product rule. It's up to you. I mean, it's entirely up to you. I'm not going to tell you which one is right or wrong, basically.
Can you just multiply the x times?
What?
You
No.
took out the 2.
I took out the 2. I'm pretending the 2 isn't there. I could have distributed the 2 to each of the top and the bottom and rewritten it that way also. Eitan?
Are you just asking like what to do now?
What would I have done? Yes. Okay. If I wanted to do that as a quotient rule. Okay. But we want to get back to this problem. How many functions? 2. Here's one inside. Here's the other one on the outside. So I'm going to go through this quickly because this is a little nasty, but I want to show you how you simplify. Based on what we did in the last problem, this will be a little different because we're going to have a quotient rule. So I put a blue dot on the screen there because I don't know how to work my own board. There we go. All right. Isn't that fun?
No.
Where did that come from?
It was the
Go,
chain
Eric.
rule. So you did the chain rule on like the main function, and then you have to put the chain on the outside, which was derivative of the thing on the inside, the function on the inside.
Well said.
You would need to do a quotient rule for, and that was really bad.
Nice.
It is.
That's not bad.
But we can simplify it. So this first, the 2 and the 5x minus 2 over x cubed minus 3 is the derivative of the outside function, which is the 2. Brought the 2 down, reduce it by 1, leave the inside alone. The stuff in the bigger parentheses behind is the chain of this stuff, which is a quotient rule. Bring the denominator down to the bottom and square it. Bring the denominator up to the top times the derivative of the numerator minus the numerator times the derivative of the denominator. Now I started multiplying. So I don't care about this right now. All I care about is the numerator here. And remember what we said in the past. Don't multiply out denominators. Don't get all fancies in your panties and decide you're going to square that, because it'll cause a bigger world of hurt. There's the last step. Now, why do we do this? Because occasionally, if you factor this carefully or you multiply it out carefully, things will drop out and cancel. This one doesn't, but they will sometimes. That's why you don't multiply out denominators, because you might get to a point where you can cancel it with something in the numerator. Okay. And again, what we've done is we've managed to take a difference here from the first step and turn it into a product, because now we can do all kinds of weird things. Set the denominator equal to 0. Figure out where those vertical asymptotes are. Set the numerator equal to 0. Find out where the y-intercepts are. You know what would be worse than this?
No.
The second derivative.
Why do I get to get
That'd be really
the
fun.
second derivative?
Oh, I'm not going to do it. I'm just throwing that out there. That would be worse.
Would we ever do that?
Yeah.
Don't give him ideas. Hit.
Don't give them ideas. Great. That's all I do at night. I go home.
Are we doing 3 functions in this lesson?
You'd swear I planned that.
Whoa, why you gotta?
That's not important. Let's skip that. Let's get to this. Ryan just asked a great question. Ryan, ask your question again.
I said, are we doing chain rule with 3 functions?
Well, son of a gun. How many functions? Ryan, how many functions?
3 functions.
Beautiful. Now, important question, Ryan. Which one's on the outside? The sine, the square, or the 4x? What is that? To the fifth. Sorry.
What's on the outside? I'd say the sine squared's on the outside.
Which one? The squared or the sine?
Squared.
The squared, correct. The squared is the outside functions. Everybody see that?
Why?
Because it's sine of x squared.
Come on, peoples.
Put the square.
This is the same thing as sine of 4x to the 5th squared. We just choose
Oh,
in math to take that 2 and bring it over here in front. Okay, 3 functions, Ryan. How many chains?
I guess three chains.
No.
2.
2 chains. Well, always one less.
Great opportunity.
There's no way to avoid it. Okay.
How many chains you got?
You want to keep going?
No.
No, that's it. You're throwing in the towel?
Yeah, that's all.
That's all you got?
Yeah.
You sure? You
You
can do this.
I'll give it a
Come on.
shot.
All right, go.
So then would it just be sine?
Nope.
Oh, 2 sine?
There you go. 2 sine of.
2 sine of
Don't overthink this.
just sine.
Of. You always have to have a
sine
sign.
of 4x. Okay.
Right. Okay.
Okay.
Good. Times.
4x.
Nope.
No.
Think about an onion now. If we go from the outside with the squared function, which is the next function inside? The sine of the 4x cubed, or 4x to the 5th.
Sine.
The sine. Good.
That's what I was thinking. That's why I
Okay.
said sine there, but
I
I just got
understand.
confused.
So times.
Just sine?
No.
Sine 4x.
Now you got to take the derivative of sine 4x to the 5th.
Is it like negative cosine or what is that?
No. Well, I don't know. You tell me. What's the derivative of sine? Times. No, you did all the hard part. Now you got the easy part.
4x. 20x to the 4th.
Good. Times.
There's more. Sine.
Times. I was tricking you. There's nothing else. 2 chains. 1 chain. 2 chain. 3 functions. 2 chains. We're done.
How many chains?
2 chains. Yeah, I got it. 2 chains. Yeah, I know. Yeah.
It's funny because like 2 chains is so rapper.
Yeah, I know. Really?
Oh, Claire, you're in for a
You
treat.
missed a lot.
Next Tuesday.
Oh, you're in for a treat. Did you plan that?
No.
Oh, it's a good one though.
Anyway, let's try you.
I'll pretend I.
Okay, can that be simplified?
I love
Let's talk about a couple of mistakes I've seen. One of the things I've seen is people recognize, oh, well, they both have a 4x to the 5th. Let's factor out a 4x to the 5th. No. Don't do that anymore. Okay? This is really bad math. This is not equal to sine times 4x to the 5th times the sine times the cosine of this other function. You have to always take the sine and cosine of something. You just can't randomly pull numbers out of there. That doesn't work. This is bad. Any ideas what you could do? Eitan?
X to the 4.
Nope.
Oh. Never mind.
Realistically speaking, oh, go Lucas.
Just factor out 2.
Yeah, won't do much for you. Yeah, but it's good. Yeah. Realistically speaking, what you're going to do is move the 20x to the 4th out in front so it doesn't get confused and get 40x to the 4th times the sine of 4x to the 5th times cosine of 4x to the 5th and be done with it. However, I will mention, this is kind of nerdalicious, I will mention that there is an identity here that you may not recognize. Does that look familiar?
Yeah, 2 sine.
Which equals?
I don't remember.
Oh, something's way wrong.
That is so ugly.
Definitely not. Oh,
Yeah, it's kind of cheap. I wouldn't expect you to be able to cover that last step. I'd expect you to get to this and then probably move the 20x to the 4th out in front, but I wouldn't expect you to recognize that. It'll come up like once the entire year. Other than this. 2 total. Sorry, I didn't mean to spit on you, Dan. 2 total, not 2 chains. 2 total. This chart,
Oh my goodness.
don't freak out. This chart is a summary of everything we've done already. It's in your book.
I didn't get my
Constant rule, sum and difference, product rule, quotient rule, power rule, trig functions, chain rule, general power rule, whatever the general power rule is. That's the power rule combined with the chain rule, actually.
General power rule.
But the general power rule, yeah, it's fine. It's my wrestling name in high school.
You must have been popular.
I was, yeah.
That's so cute.
What's the matter?
Where do we find this chart?
I believe it's at the back of 2.4. Okay,
It's in the book.
are we good?
Isn't it
Molly.
day 28? Yeah, he said he's
Are we on day 28?
Yeah.
My assignment sheet is different than yours, so it is day 28. Olivia, what's that?
The general power rule is the chain rule combined with the power rule.
You got it. Like the very first example I did where you have something raised the second time.
Are we speaking?
Okay, so